Why does compressive stress make materials fail? Imagine squeezing a sponge until it crumbles or pressing down on a metal rod until it snaps. These everyday examples show how pressure can cause things to break. But what really happens inside materials when they are compressed? Let's explore how compressive stress can lead to failure in different ways. Compressive stress is the force applied per unit area that pushes or squeezes a material together. Every material has a limit called its compressive strength, which is the maximum stress it can handle before it starts to fail. When the load exceeds this limit, the internal structure of the material can no longer hold together, leading to cracks or fractures. One common failure mode is buckling. This happens mostly in long, slender objects like columns or beams. When compressed, instead of just shortening, these structures bend sideways and suddenly collapse. Think of a tall, thin straw bending under pressure. Buckling is quick and unstable, often causing sudden failure. Another way materials fail under compression is through yielding and plastic deformation. Ductile materials like metals can stretch or bend when pressed, but if the load keeps increasing, they reach a point called yield. This means they permanently change shape, bulging or barreling out. If the stress continues, the material eventually breaks because it can't handle the deformation anymore. Brittle materials like glass or ceramics tend to crack rather than bend. Under compression, they often split along their length in a failure mode called axial splitting. This occurs because when compressed in one direction, the material tends to stretch or strain in the perpendicular directions. If it can't resist these side strains, cracks form and spread, splitting the material apart. Shear failure is another possibility. Inside the material, compression can create internal forces that cause parts to slide past each other along certain planes. This is common in natural materials like wood or bamboo, where the internal grain structure guides failure along specific directions. The presence of lateral pressure, or confining pressure, also influences how failure occurs. Without enough sideways pressure, brittle materials are more prone to cracking and splitting. But with moderate confining pressure, they can deform more before breaking. High confining pressure can even make brittle materials behave more like ductile ones, allowing them to stretch or bend before failure. Understanding why compressive stress causes failure helps engineers design safer structures. They choose materials with enough strength and ductility, shape supports to prevent buckling, and add reinforcements to resist shear and splitting. They also consider how loads are distributed to avoid stress concentrations that can trigger failure. In simple terms, when a material is compressed beyond its ability to resist internal forces, it fails through buckling, cracking, or deformation. The specific failure mode depends on the material type, shape, and how the load is applied. Recognizing these factors helps us prevent mechanical breakdowns in the products and structures we rely on every day.